We're going to take some measurements of some light bulbs and kind of compare them against each other, and also compare using the gamma flasher and compare the frequencies that each light bulb emits. The light bulbs we're going to look at are these light bulbs right here. Basically, I have a fluorescent light bulb. It's a 13 watt, 60 watt equivalent. This is an old-fashioned 60 watt incandescent bulb. This is a Walmart light bulb. It's 15 watts. It's equivalent to 100 watts. It's actually a pretty good light bulb. This is a 14 watt light bulb, 75 watt equivalent. It's also a Walmart light bulb. It turns out to be pretty disappointing, and I'll show you why in a little bit. This is a very good quality GE light bulb. It's 15 watts, it's dimmable, it's equivalent to 100 watts. And this is the non-dimmable version of it. Also a very good light bulb. This is the version that I usually send with the gamma flasher. I really like these two light bulbs, although I may start sending these also, because this is actually pretty good, and I'll show you in just a minute. Let me go over the setup I have here to evaluate these light bulbs. I have a power supply here on the right, and I have it set to 5 volts. I have an oscilloscope that we're going to look at the light with. And then down here, I have this circuit right here set up. As you can see, I have my power supply depicted on the left, going through a resistor, 3.3 kilo ohm, going to a photoelectric transistor. I'm using the NTE3037, and I have my scope hooked up to the resistor side. Here it is right here. I have it set up in a vise so that I can move it around, adjust the intensity of the light being received to it by adjusting it. There's the resistor. I picked 3.3 kilo ohm because I just happen to have that as a strip of resistors. And as you can see, this is my ground lead. I have the scope ground plug tied to it, and got the negative side of the power supply tied to it. This right here is the 5 volt lead coming from the power supply, and this is the lead that goes to the collector of the photo transistor. And this is the oscilloscope probe. And at the moment, if you look at the oscilloscope probe, it's set to 5 volts. Here's a list of the light bulbs that we are looking at. There's a 13 watt light bulb. It's a 60 watt equivalent. And what we're going to see is it's a fluorescent light bulb. We're going to see it actually flutters at 120 hertz. It's made by GE. There's the old-fashioned 60 watt light bulb. It's incandescent, and we're also going to see it fluctuate 120 hertz. There's a 15 watt light bulb. It's this light bulb right here. It's a Walmart brand. It's the LED 15A21N1. I'm going to show it just normal. It's actually a really pretty good light bulb, even though it's made by Walmart. We're going to see normally it'll fluctuate at 120 hertz. If we use the gamma flasher LLF 200, we'll see it fluctuates at 40 hertz. Then we're going to look at another Walmart light bulb, the LED A19041. It's a 75 watt. It takes 14 watts to power it. It fluctuates at 120. But it has problems, and again, I'll show you that. With the lamp flasher, it fluctuates at 40. And then we're going to show 2 other light bulbs, both made by GE. One's a dimmable light bulb, and one's a non-dimmable light bulb. They're the LED 15D for dimmable, A21, A27, and the LED 15A21. They both consume 15 watts. They put out 100 watt equivalents of light, like the old 100 watt incandescent light bulbs. As you would expect, 120 and 40 with the gamma flasher. So, let's get to it.